Modeling with linear functions. In this video, we'll look at an example of how you can use a linear function or a line to model a real-world situation. So let's look at this example. The sales for Nike were approximately 25.3 billion in 2013 and 27.8 billion in 2014. Part A says, find a linear equation that gives sales in terms of the year t years after 2010. Okay, so we need to find a linear equation to model this situation. In particular, we're told that we need our linear equation to give the sales in terms of the year, t. So that means that our linear equation, we want it to have the property that the sales are the y-axis, that's like the output, and the years, t, that's the x-axis. How do I know that? Because we want to have sales in terms of t, which means sales is dependent on time years. Okay, so I always start out by drawing an x and y axis and labeling them according to what we want in terms of the other variable. At this point, I'm going to try to plot 2 points based on the information given. So I'm going to try to plot 2 points based on the info here so that I can then find a line equation to connect them. So we're told that the sales are 25.3 billion in 2013. So the sales are 25.3 billion in 2013. So what I can do is I can plot a point at 2013 and 25.3 billion. Like right there. We're also told that the sales are 27.8 billion in 2014. So I can also plot a point at 2014, 27.8. Like that. Now, there's one extra little thing we're told here, which is that we want to have our linear equation in terms of the year t years after 2010. So what does it mean to do the equation in terms of year t years after 2010? It means we're going to start at 2010. That's like our starting point. In other words, that's like our 0 year, which means I'm going to rescale things a little bit, and I'm going to call the year 2010 0. I'm going to call the year 2013 3 because it's 3 years after 2010. And I'm going to call the year 2014 4. So instead of labeling on the t-axis 2010, 2013, 2014, I'm going to label them 0, 3, and 4. And that means I'll label this point here as 3, 25.3. And then the second point here, I'm going to label it as 4, 27.8. Okay, now what's the point of drawing this picture and labeling 2 points? Well, the point is this. We can now connect these with a line, and we can figure out the equation for this line using what we know. How do we find the equation for the line? Well, we need the slope. So I can take a look at this picture, and I can find the slope of the line. How do I find slope? I do y2 minus y1 over x2 minus x1. So it doesn't matter which point you pick to be the first point and which one is the second point. Perhaps I'll go with this one as x2, y2, and this one as x1, y1. Now, if I plug into this formula here, I get 27.8 minus 25.3 on the top. I subtract the y values, and then I divide by what I get when I subtract the x values. So if we simplify this, we get 2.5. So the slope of this line is 2.5. Once I find the slope of the line, I can use our y minus y1 equals m times x minus x1 formula to find the equation for it, because we know 2 specific points. So you only need at least 1 point and the slope to find the equation for a line. So I'll write down this formula. Y minus y1 equals m times x minus x1. And I'm going to plug in a specific point. I'll pick this first one. So we'll plug in for y1, 25.3. And we know m, we just found it as 2.5. And then for x1, we'll plug in 3. Now, if I'm looking at this, there's something that's a little bit strange, which is that my x-axis is actually supposed to be in terms of t. So if you go back here, we want x-axis in terms of t. And then my y-axis is sales, and so maybe I'll call that S. So instead of using y and x here, I'm going to switch them to S and t. I started out with y and x because they're more familiar to you guys, but I'm switching to s and t to make this more relevant to our picture, where the x-axis is actually the t-axis and the y-axis, we'll call it the s-axis. Okay, where do we go from here? Technically, we have our linear equation at this point, but it's useful to solve for s, and you'll see why soon. So if we solve for s, we get, I'm distributing 2.5. And then if I add 25.3 to both sides of this, I get the equation in terms of t, or I get s in terms of t. Okay, now I'm going to call this s of t to emphasize the fact that on the right we plug a t value in. What is this function here? It's a linear function that gives the sales, or s, in terms of t, the number of years after 2010. Okay, let's look at part B. Part B says, use your equation to predict the sales in the year 2017. So we want to know what the sales should be in 2017, assuming they follow this linear pattern. So our linear equation is S that we just found is S of t equals 2.5t plus 17.8. Now, we want to predict sales. We want to know what S is when t is a specific value. Now, they say to predict the sales in the year 2017, but we don't want to plug 2017 in for t, or years, because t is supposed to be years after 2010. So let's think about how many years after 2017 is. So 2017 is 7 years after 2010. So what I'm going to do is I'm going to plug in 7, or t equals 7, to predict the sales in the year 2017. So if I plug in 7, and simplify, I get 35.3. So we're going to predict our sales to be 35.3 billion in 2017 based on our linear equation. Okay, let's look at part C. In approximately what year will Nike's sales be 40 billion? So the question is, when will S of t equal 40 billion? We know our equation for S of t is equal to 2.5t plus 17.8. And we want to know when is the output 40. In other words, for what t is the output 40? So what I'm going to do is I'm going to plug 40 in for S of t, because they want to know when are the sales 40 billion. So when is S 40 at what t? From here we can solve for t. So we get and then if we divide both sides by 2.5, we're going to get a specific T, 8.88. Okay, now the question was, in approximately what year will Nike sales be 40 billion? Now we got this decimal answer, T equals 8.8. So it's somewhere about 8.8 years after 2010 when the sales will be 40 billion. In the 8 years after 2010, it hasn't quite reached 40 billion yet. So what I'm going to do is I'm going to round this T up and say that in approximately year 2019, which is 9 years after 2010, so I've added 9 to 2010, the sales will be approx 40 billion. Now, in 2019, they'll have surpassed 40 billion by a bit. We can see that 8.8 years after 2010 is when it reaches exactly 40 billion.